So in section 5.2, we're looking at equations of straight lines. And when I'm teaching this in a lesson, I'll have a whiteboard, and I'll say to the class, okay, look, imagine a line on that whiteboard and describe that line to me. And there are two options really that people can come up with. They can say, well, it's the line that goes from, usually people say something like, well, the top left-hand corner of the board to the middle of the bottom of the board. So what I've said there is the top left-hand corner and the middle of the bottom. I've given you 2 points and I've drawn a line through those 2 points. So that's enough to describe a line in real life. So there should be an algebraic equivalent of that, right? We should have a method for, if I give you 2 points on the line, then we can find the equation of the straight line. And the other option would be, someone would say, well, it goes through, it hits that point there. So there's a point about, and then they describe this point here. And then they say, well, and then it goes at a very steep angle with a positive gradient or something like that. So the other way of describing a line would be to have a point and then a gradient. Okay, so if I've got a point and a gradient, so 2 points, that's one way of describing a line. There should be an algebraic way of if I give you 2 points, it's the line that goes through the 2 points. That's enough to describe a line. We should be able to find the equation of the line algebraically if we're given 2 points. If I'm given 1 point and a direction, and the way that we think of direction at this point is the gradient. If I give you a point and a gradient, that should be enough to describe a line, so we should be able to work it out algebraically if I'm given a point and a gradient. And the other way of doing it would be to say, well, it hits this point, this line here, halfway up, and then goes at this steepness. And that's the y equals mx plus c form, isn't it? We tell you where the line hits the y-axis and the steepness. So I'm going to put that one in brackets, y equals mx plus c, because we're already familiar with that one, okay? So, if we have, we'll start with this example here, because this is the one that they look at first in the textbook in section 5.2. If we have 1 point and a gradient, that should be enough to find the equation of the line. So how does that work? Well, if I know it goes through a particular point here, then the particular point we'll call x1, y1, okay? And just for clarity, let's say this is something like the point 2, 3, okay? Then any other point on the line has the coordinates x, y, and I need to know the link between x and y if the line that I'm looking at goes through x1, y1, and let's say it's got a gradient, we'll keep the numbers simple, let's say it's got a gradient of 2. Okay, so how would that work? Well, what I know is that if I take the y change and the x change, so y minus y1 divided by x minus x1, okay, so this distance here and this distance here. So if we're doing this with the numbers, that would be y minus 3 divided by x minus 3, okay? So whatever this point is here, take away the y coordinate here. Whatever this x coordinate is here, take away the x coordinate here. So y minus 3 over x minus 2 there. Now, it's important that this x and y are any x and y. I can't replace these with numbers because this could be any point on the line. Okay, if it was this point down here, I'd be getting the same thing. This would be the point xy, and that distance there divided by that distance there would give me the same gradient. So if I do that calculation, I get the gradient, which in this case we said is 2. Okay, so we get the gradient, which in this particular case is 2. Right? So there is my equation of the line. That's the formula, that's the process that I go through, and here is a particular example. Now, if we've got this particular example, look, that's not a nice version of the straight line graph equation, so we're going to have to rearrange it, okay? So y minus 3 equals 2x minus 4. So for this particular example, we might want to write it as 2x minus 1, y equals 2x minus 1, and we might want to write it as y minus 2x plus 1 equals 0. Those two lines there give me the y equals mx plus c form and the preferred, the standard version that we met in section 5.2 of the straight line equation. This thing in the box here is usually remembered as y minus y1 equals m x minus x1, and that's just a formula for the equation of a straight line That's the y-coordinate of a point on the line, that's the x-coordinate of a point on the line, and that's the gradient. Okay, so we should know where it comes from at A level, but really if I'm told 1 point and a gradient, I just put them into that formula. Then I've got a formula that links y and x. It might need a bit of simplifying into the standard form or the y equals mx plus c form, but that is the formula we're looking for. Okay, and that's the first thing that they give you as an example in section 5.2, and example 6 and example 7, and indeed exercise 5c deal with that sort of thing. Okay, now the next thing that we need to deal with is if I know 2 points on the line and I want to find the equation of the straight line. So if I know 2 points on the line, let's say I know this one and this one, and these are specific points this time. Okay, so I know this is x1, y1, and this is x2, y2. Okay, well, if I knew the gradient, then I'd be sorted here, wouldn't I? Because I've got a method, we just looked at it. If I know 1 point and a gradient, I've got a method. So if I only knew the gradient, well, I do know the gradient because I know these 2 points. So the gradient is y2 minus y1 over x2 minus x1. So there's my gradient. And then I can use the formula that I've seen before. So y minus y1 equals m, well, that's the gradient. So y2 minus y1 over x2 minus x1 times x minus x1. Okay, so what I'm doing there is I'm using this formula, y minus y1 equals m x minus x1. I've got y minus y1 equals, this bit here is just an m, isn't it? That's another way of writing m, x minus x1. So I can rearrange that formula, and y minus y1 divided by x minus x1 equals y2 minus y1 over x1, x2 minus x1. So for the people that like this formula, that is the version it's usually given in. Now, I would strongly recommend you don't bother with this formula. We're looking at it because there are lots of questions where you're given 2 points on the line and you need to find the equation of the straight line. The way to think about it, though, is follow this process. What we did was we found the gradient and then we used that formula. So I would strongly recommend you get this idea of y change divided by x change into your head for the gradient, and you remember this formula, and that will do the job in any situation. If you particularly like memorizing formulae, some people do like to know this one as well. I would be very careful with it because the ones and the twos easily get mixed up, but I'm showing you because some people find it useful, and maybe some of those people are watching these videos. Okay, so there is one new technique there then, which actually isn't, strictly speaking, very new. We've been able to do this before. You may not have met this particular formula, but we have seen this before. If you're given a point and a gradient, you can find the equation of the line. Now, you need to really get that into your head as a technique that you have. If you've got a point and a gradient, you know the equation of the line. Because when the questions get difficult, it may be even in exercise 5D, but certainly when we get further through into the chapter and look at the mixed exercise, there's lots of questions where you're being asked to find the equation of a line. And if you can think to yourself, right, what do I know about this line? Do I know a point on the line? And often the answer is no, and you have to think, right, well, can I find a point on the line? Do I know the gradient of the line? And often the answer will be no, and you have to think, right, well, can I find the gradient of the line? If you know a point on the line and you know the gradient of the line, that's enough. That's enough to find the equation, okay? A lot of people that get stuck on the questions because they're sitting there thinking, well, how do I find the equation of this line? I don't know anything. You know, I don't have a technique to get from here to the equation of a line. And you need to think to yourself, do you know a point? Do you know the gradient? And if you know those two things, that should be enough to get you there, okay? That is everything on section 5.2. So we'll carry on in another video.